would like to invite Mr. Atul ji. He is the industry veteran. He is around more than 3 decades of experience. He is the founder and CEO of Ultra Fast Chargers. So earlier he was heading different organizations. He started his own companies. And he is an expert in power electronics and particularly in the EV. And I believe that they are developing one of the latest technologies about the ultra fast chargers. I'm sure we will be enjoying his session. Over to you, sir.
I'm Atul Srivastava here. I am from Ultra Fast Chargers Private Limited. So the topic of DC fast charger is 50 to 50 kilowatt chargers. So what happens, what is the basics of ultra fast charger? Ultra fast charger is only for public charging. So any vehicle which you know, vehicles can be charged in your home also. But what is a public charger is basically, it is replacing all petrol and diesel stations going ahead. So what is going to happen? By 2030, depending on different countries and again, depending on India, about 50% petrol and diesel stations will be replaced by DC fast chargers. By 2035, many of the electric vehicles which are IC-based petrol and diesel vehicles will be stopped, and almost 70 to 80% public chargers will be replaced by the DC fast chargers. Now I'm talking about 50 to 350 kilowatt, but we'll seeing ahead. This DC fast charger, there are different kind of technology which we'll be seeing through what are the different technologies happening. What we are presenting here is what is the world-class DC fast charging. So top companies like ABB is there, Delta is there, Tritium Charger is there. Why this should be done in India? That also will be saying that, what we are going to do here. And as we say, everything should be Atmanirbhar, that it should be done in India. So that is the topic. So this is the e-vision here. What is the vision here for the DC fast charger? So the vision which is there is, first I told you replace all electric vehicles eventually, maybe, I don't know, maybe 8 years from now, 10 years from now, 15 years from now, but all your petrol diesel stations will be replaced. So we have to be prepared. Second thing is charging time. One is very important things, that charging time for electric vehicles all over the world. Whatever I'm talking is not only about India. This is what I'm talking, everything globally. Global charging for electric vehicles is from 20 to 60 minutes for charging. Whichever vehicle you say. So 20 to 60 minutes average for charging. So at a time, suppose 10 vehicles, like whatever happens, 10 cars goes to your charging. What will happen? Are you going to wait for 3 hours to charge it? You are not going to do that. So what is the vision is, first, it should be all EV charging stations. The number of bays should be maybe 10, 15, maybe even 20 bays, because once you go for your vehicle, you are not going to wait here. You say, every charging is 20 minutes, I'll go there, some bays should be available, and you should just get it charged for 20 minutes. And there are different types of chargers which will be going through. So what will happen? That presently, if you see across the country, a number of DC fast chargers across the country, maybe less than 200. By 2030, it can be 50,000. What is the growth you can see? And that's why not one company, 2 company, 3 company can do it. There will be several companies which will be required, which can fuel this growth. The tremendous growth is going to be in DC fast chargers. Let's see what happens. Even in the very beginning, we say, there's a UN climate conference. There's a UN climate conference across the world. All the countries are discussing and all. So what is the push? The push is electrical vehicle should be promoted by all the countries. So what is the push there? That electric vehicle should be pushed by each countries. It means convert more of your IC engines with electric vehicles. So what is happening here? You see US, China and India. US, China, and India are the major importers for petroleum products. They have two requirements. First, there should be environment. As you can say, our CO2 emission is 286 million ton per year, only for transport sector. And we are giving almost 8 lakh crores. We are importing for petrol and diesel. So we have two requirements for India point of view and also for US, China, and India. That for both the regions, for economic region, as well as for the your climate region, electric vehicle should be promoted. It means more and more electrical vehicles should be promoted in the country. And that you can see there are many advantages. First, so when you are saying 8 lakh crore of your petroleum products is coming in India, equivalent to that is what going to happen. Equivalent of electrical energy generated in India, maybe with solar, maybe with wind, maybe your coal power, whatever. And there will be equally people will be having all the employment generation also in India. So there are all advantages we are having. And running cost is very cheap. We'll be seeing one slide. What is the cost of electric vehicle? And one thing, the last thing, global companies will stop IC engines by 2035, most of the companies. So what will happen? 5 years from now, 6 years from now, you will be not buying your IC-based your vehicles. And so electrical vehicle will be, my personal thinking is by something like about 2032, 10 years from now, 90% of your electric vehicles will be there in India. So now coming to, these are all different electric vehicles in the world. All different electrical vehicles. So if you go to your exhibition today, you can see all the exhibitions today. 50% of exhibitions will be in two-wheeler and three-wheeler in India. This is what India is going to do it the first one. Because India starts everything little slower than others. First thing is there, two-wheeler and three-wheeler, and start moving to low-end vehicles, cars, SUVs, economy, mid-end, high-end, city bus, LCV, and going to long-haul heavy trucks. This is for all over the world. Okay, so what is important from your point of view? Starting from just focus for electric vehicle technology and this thing. Voltage is 48 volt. Your battery is 2 to 5 kilowatt. The batteries are measured in terms of kilowatt hour. You can see that for a two-wheeler, 48 volt technology, 2 to 5 kilowatt hour, due to long haul trucks, 400 to 1000 volt. 400 to 1000 volt, and the battery is going up to 1000 kilowatt hours. This is what is going to happen. This is again, repeatedly I'm telling, even though I'm repeating, nothing for India. This is for all over world. And unless we reach to the first one, because we will see one more slide for that. Now you see the most interesting thing here. What is the running cost of vehicles for India? Now this is very particular to India. What is the running cost of different vehicles? So if you say we are talking about two-wheeler, running cost can be as low as 22 minutes per kilometer. That's what if you go to all this, your exhibition you see there, people will talk about it. What is your ownership? Okay, what is the ownership of your vehicle? This is a 22 minutes. And if you go to slowly, so even if you talk about car, and just now I think Tata Tiago is again launching today in a big way and all. What will be the cost? Will be 1 rupee per kilometer for Tata Tiago. Okay, it's a 72 volt technology in that. So what we are saying that, okay, for all the vehicles there is an ownership, and again depending on different kind of vehicles and all, but the range is, this is very particular about India itself. And I'm costing, say, 1 kilowatt is 1 unit, whatever is your electricity in your home, that's 1 kilowatt is 1 unit is something about 10 rupees and all. So I'm just giving you some kind of comparison. if you have a large truck for 3,000 kilometers in India, the diesel costs 1,200 liters. And the cost of diesel is 1,08,000 rupees, 90 rupees, if I say diesel cost. If you same thing you are doing, a large truck for 3,000 kilometers, it will cost 6,000 kilowatt hour, and the cost is 60,000 rupees. Now, you all know which vehicle takes maximum diesel in India? Trucks. So unless we are able to, as I told you, this one, as you reach there, now we are starting from bottom in India. As we go to the top one, okay, we will not decide. But this is very important, and that is why if everybody puts in their mind, okay, what is the range, what is the cost of ownership and all, then people will understand why EV is important for you. You see, this is the 1,000 kilowatt hour long haul 35-ton truck from Germany. This is the ultimate, which will take us 5 years to reach there. Okay. What is important for this one? The battery is 1,000 kilowatt hour. You have seen here 2 kilowatt hour battery. Top one we are saying, because we are in the charging business. This battery requires 1,000 kilowatt has to be charged. It will take you full day if you don't have a fast charger. So your bus, trucks and all, we will see. But this is the ultimate thing. Have a long haul 35-ton truck which can single charge. It means you Kanyakumari charge this battery, it will reach to Srinagar without charging. This is ultimate. And this is what we should aspire, and this is the vision I am talking about. What is the vision? Vision is what? If you talk, okay, what will happen tomorrow or next month or this year? Vision means what? You should be able to see. People in the world who can have vision farthest, they will think the best. I am talking 5 years from now, if you are able to do it, you all will see it after 5 years whether we are able to do it now. So now we go further. Now you know the batteries are there, 2 kilowatt hour is there, whether every chargers are same now. They are all the chargers in the world. They are AC charger, slow charger, AC fast charger, DC fast charger, 50 to 350 kilowatt up to 500 ampere. This is what is the, we are from ultra fast chargers. In this business, 50 to 350 kilowatt DC fast charger business. And there's another charger in India, it's called a Bharat DC 00. It's specifically for 72 volt vehicles. Somewhere is the cheapest vehicles which we know, like E-Verito, Tata Tiago, all those vehicles. And there's swapping stations for two-wheeler, three-wheeler. You can go there, they can just swap it and all. Okay, so we know there are different kind of charger levels are there. Now, which are the chargers are also different. For India, we are having a CCS2. Okay, CCS2 for Europe and India. Japan is CHAdeMO, 200 kilowatt. China, we have a GBT. Some of our Indian vehicles, they are based on GBT from China. Tesla is a 250 kilowatt. Now coming to megawatt charging. Megawatt charging is again for vehicles ahead. So this can charge up to 3.55 kW, but ultimately so 1 kilowatt is fine. So this truck will be charged in 30 minutes. 1,000 kilowatt will be charged, and that's why this is called 1 megawatt. This is again, it will take us 6 years from now. 2028 we'll have this. I'll try to make it faster in India, but in the present course, what is at 1 megawatt is going to that much time. And you can see all different vehicles, all across all Indian vehicles here. You can see that they can handle from 50 to 350 kilowatt, all different vehicles. So why we need CCS2? Because our technology CCS2 and it looks like that. So now coming to why I'm talking about chemistry today. Because two reasons. Most of you have forgotten about what is called periodic table. I don't know whether you remember in your schools. Periodic table. Don't know. Okay. So if you see periodic table, okay, you can see helium, hydrogen, helium, last is lithium. Why every battery is a lithium battery? Because lithium is the lightest metal in the world. By nature, lithium provides us, but lithium is very costly. And so what people do, they make different kind of combinations. Okay, they are saying, you can see all those different types of chemistries. Why chemistry is important? Because electric vehicle, these electric batteries are the costliest part in electric vehicles. And if we want to make a cheaper vehicles in India, we have to do research to make new kind of chemistries so that we can make cheaper batteries. And that's why I told you why it is required. India needs battery chemistry. We need all the people know about chemistry. There are people maybe many PhDs with knowledge about chemistry and different kind of. If India can do new chemistries and all, we can change the world. It is so important. So this is required. Other than that, if you see that, okay, what is in the vehicle? So why vehicle and the charger both are related? Because it is the same technology. So the power electronics is here also, power electronics is there also. We are doing what? In a charger, what we are doing? We are taking from grid AC, we make DC. What happens in vehicle? When the charger is become DC, it becomes AC. So you have permanent magnet, synchronous motors, which is required. So there are a lot of technologies. So if you see for India, we need new battery chemistry, PMSM motors, power electronics, and all kind of software. In the charger as well as in the vehicles. You know Tesla. Tesla is world's best cars. What is inside Tesla? Same battery, what we know. Okay, it's 100 kilowatt hour, something like if you say Tesla Model S, if you say it's 100 kilowatt hour battery, we know battery. PMSM motor, we know PSM motor. Power electronics, same power electronics. Okay, together it costs $15,000. What is next $50,000 in the vehicle? Software. So main thing is software, whether you a charger or vehicles. So what about India? We don't know software. We don't know how to do about software. We can surely do about software also. So there's a ton of software. That's why I just noted. So why I brought into picture this chemistry thing, and it was very important. So now you see the overall. Okay, you see the vehicle. Say some top sort vehicles. Say 100 kilowatt hour battery, range is 650 kilometer, and you say maximum charge is 170 kilowatt battery voltage, and it can charge 200 kilometer in 18 minutes. This is top notch. Most likely this is the Mercedes, new one, EQ. So this is what is there. What we need, say we are in that business, 50 to 350 kilowatt charger. What is this? 170, we can surely do it. So top of the notch, we can do it. But still you see, I told you in the beginning, when we make it vision, what do we say? It will still take 20 minutes to charge. Even if you have top notch, even if you say Mercedes, it will take this thing. So what we are saying, why we need more base, because still we need to charge more number of vehicles, you have to have more number of base and all. So what happened here, we are saying we can have 200 kilometer range, that is what, and it can charge in 18 minutes. Is it the fastest one? Is it the fastest one? No. So you can see which are the best in the world, the fastest charging in the world, 320 kilometer, top notch, Porsche Taycan, Lucid, Ioniq 6. They can just go to the charger, 7 minutes charging done, 200 kilometer range, and zoom. In the India, where we are in now, Tata Nexon, MG ZS EV, something about 60 minutes of charging. So maybe ultimately we need vehicles which can charge faster, and we need more chargers, more DC fast chargers and all. This is important. So the first part I told you, that if you want to make DC fast charger, what is requirement? How do you design? Anybody of you, how you design DC fast charger? First thing, you need a CCS2 type of cable, the top one. You need a DC rectifier, which is a Powertronics. And everything is controlled by software called ISO 15118, that is the protocol for that. And rest of the stuff, let's not worry about that. So these are all the major sub-assemblies. Anybody who wants to make DC fast charger, you need all these things and all. So I'm just giving you, this is like a rectifier, which we are presently doing it in India. So you can see, voltages are 150 to 1000 volt. We are handling. So if you see all the vehicles, we are tackling what? 150 to 1000 volt. It means all vehicles other than 72 volt cars and two-wheeler, three-wheeler, they are in the realm of DC fast charger. Okay. So you need a rectifier of this type. So what is the technology inside the rectifier? So this is the most complex thing, and any of you in India who wants to, unless you do solve this, rectifier solve this problem, you will not become your own Atmanirbhar kind of thing and all. So this is very important. So what it requires is the silicon carbide MOSFET. This is the new technology, different controllers, lot of software, and lot of software for designing also, like a MATLAB, your SolidWorks, all those stuff. Okay, so rectifier is the main thing. What is rectifier happens? You get AC from your grid, whatever is your grid, normal. That is 415 volt, 50 hertz. And you convert it into DC. It's simple, but it requires a lot of, it is handling that much power. And that's what this main unit rectifier is one of the most important thing inside. So what you tell you, that DC fast charger, see, this is from ABB, this is a 360 kilowatt charger. Okay, so that side you can see, because the companies like Lucid or Ioniq or Porsche, they can charge it that faster, this one. So this is what is required, this is the ingredient required, this is the recipe of, so this is inside, I'm just seeing you just photo, okay, inside our product, how does it look like inside that, what is the rectifier is there. One interesting thing from your point of view, each your electric vehicle and the charger, this is just like computers. Okay, so don't think that they are dumb things, dumb electric vehicle and a dumb charger. They are working like computer. Okay, they are having IP addresses. Both of them are having IP addresses and they communicate with each other. Okay, and so that there is no hacking is done by somebody, your car and all. They are only communicating through the inside your charger. If you see here, this the top, this is what inside that only there is a communication between your electrical vehicle and the charger, and the standard is called ISO 15118. So you can say power line. It goes power line over the, okay, so this is something very interesting. So both the vehicles, they are communicating over power line, and that's what they have. And then you have a tons of other software. These are all different kind of technology software which is required. So I told you in the initial, there is a software on this side and this side also. There's so many software, different kind of software which are part of your electric vehicles and all. And now if you see, we told you in the beginning that, okay, we'll have a, say, DC fast charger across India. How many? Thousands of chargers. Something in Arunachal, something in Rajasthan, something in India. How to control each one of them and all. So there's another kind of software are there. So everything is software. So this is also so many different kind of software like the load balancing, smart metering, tariff, roaming, all those things. And last thing, this is the ultimate, you say, for the charger point of view, what they say, this is the most important, the last one is called the PNC, pay in charge. Pay in charge, what happens, I told you that electric vehicle and the charger, they are just connected through a communication between them. There's a very, very secure system is there inside that very secure system is there. You just connect it, it will get charged. No billing, no app, nothing is required. This is the PNC, some of the top, say, companies in Germany and other countries. Hopefully in India also, maybe another 5 years from now, Okay, something called a PNC. We are also trying to work on the PNC side also, that you just connect it and it will get charged. All billing, how much, everything, all communication will happen automatically. This is the ultimate thing which is there. So what we told in the beginning, we have a vision. I told you with you, what is all this different vision to make such a thing in India. So I'm ending with, this is a vision. Let us do it. And we'll be part of it, and not one or two people. Several companies will be needed, thousands of companies, and at least few lakh software engineers. If they have been fired by the other companies and all, okay, Twitter and all, they can come here because there's a lot of software people are available in India. Thank you. If you have very quick one or two questions, I can answer you. Yeah, so this is the common question everybody asks. The nature of your lithium batteries is such, fast charger is only applicable for 20 to 80% charging. And that will not impact the life of your lithium batteries. So if you are seeing any specification, if you see any vehicle, if you see specification for DC fast charger, they will give you specification for 20 to 80%. Because what happens, 0 to 20% you should work on a slow charging, basically constant current charging, and DC fast charging applicable for 20 to 80%, and that's why it will not impact the life of the vehicle, life of the battery.
You said that lithium-ion batteries are the major components in an EV charger, and lithium extraction is not the best bet for our environment because one of the major USPs of EV technology is being sustainable. So are there any alternatives that we are looking at, and how are we planning to tackle this issue?
Okay, thanks. It's a very good one. Almost for 5 years, people are working in this domain because lithium is very costly also. Yeah. Okay, first of all, it is a rare metal and it's very costly also. So that's why one of the slides you would have seen that I told about the chemistry, because lithium is made out of your cathode, anode. Okay, so what happens, what you do, you mix other metals also. Okay, so there are different metals are there depending on the manganese is there. Okay, then the iron is there. That's why you see some of the cheaper batteries, you say lithium phosphate. Lithium iron phosphate. Why? Because you are mixing iron with lithium. So people, that's what I told you, the requirement that why we have to make a cheaper batteries, because lithium should be less. Okay, lithium should be as less as possible, and that's why this is a requirement that we should develop new chemistries. There already people have done. Okay, so like NMC is the costliest one, so all your top-notch batteries will be NMC, while lithium iron phosphate is the cheapest one, but we should do a still cheaper one.
Firing incidents in terms of safety. So what are the precautionary steps being followed, and as well as software based it is, so hacking incidents may happen, so it may create a security issues. So what are the steps being observed by these EV manufacturers?
Yeah, very relevant one. Yeah. So what happens, we are talking about two-wheeler and three-wheelers and all. Yeah. Okay, so the system of all your four-wheelers which I talked to you about, there is a standard called ISO 15118. Okay, so what happens, this will take care that, okay, everything is done, and the vehicle itself, I told you earlier, there is a communication between vehicle and the charging. Such incidents is not likely to happen and all. But in a lot of people who wants to make the cheapest product at the quickest timing and all. So what they say, they don't follow the rules properly. Lithium batteries are very sensitive things. The way you store it, the way you charge it, the way you are putting the vehicle, there is a standard there. People should follow that. Similarly, hacking, if you are doing a software. So for charging for all the four-wheelers, what happens? Whatever you do app, inside app again it has to go through the protocol. So four-wheeler will be protected. For two-wheeler and three-wheeler, we need some kind of additional safety measures, which you should not bypass those things. Okay, thanks a lot.
One thing I am taking away from the Atulji's talk is, it's not a charger, it is a computer. So I think there's a lot of software, a lot of hardware going to come up. And I invite Madam Anjana Sinha ji to please come over and give a token of appreciation for us.